Welcome to today's lecture. Last class we have seen phase locked loop. In phase locked loop we have seen two variations. One is non-linear method, another one is linear method. In today's class we are going to see FM transmitter as well as FM receiver. Before going to see what is transmitter and receiver, we will see some basic fundamentals of transmission, particularly in FM transmission. In the previous lectures we have seen AM transmission. Now we are going to compare what are the parameters which are differ in FM. The frequency range for AM modulation is 550 kHz to 1605 kHz, 1605 kHz. In FM transmission, the frequency range is from 88 MHz to 108 MHz, which is in the range of very high frequency. Here, this is medium wave band, generally used for ground wave propagation. If we are using a short wave, that is 3 MHz to 3 to 30 MHz, then we have to go for sky wave propagation. SW stands for sky wave propagation, GW stands for ground wave propagation. Audio frequencies which can handle up to AM transmitter can handle up to 5 kHz. In FM signal, it can handle audio frequencies up to 15 kHz. The bandwidth or channel spacing is allowed in AM transmission is 10 kHz. In FM transmission, allowed bandwidth is 200 kHz. Therefore, we are having sufficient channel spacing. Here, in out of 200 kHz, 180 kHz is, as per Costin's rule, 180 kHz is the bandwidth. Remaining 20 kHz is used for the guard band to avoid interference or crossover frequency. This is as per Costin's rule. Only 180 kHz is used for the bandwidth or channel spacing. So these are all the fundamental parameters which we must be aware of before going for this transmitter and receiving section. In one of the application of FM transmitter is FM stereo multiplexing. What is stereo? Then we have to see what is monophonic. We have seen the monophonic is the no variations in the sound in left as well as in the right. But in stereo sound, we have different type of information in the left microphone. Generally, we have used the hands-free. This is for left and this is for right. So in stereo, we have two different signals coming from the left as well as in the right microphone. So how this type of information is passed through the receiver, and we are going to see how this type of monophonic information is passed through the receiver. In FM stereo broadcasting is specifically concentrating only on the stereo multiplexing, as well as we are going to explain how the same transmitter can be used for transmitting monophonic set of signals. So this is the block diagram for FM stereo transmitter. Here we are having from the left microphone, assume this as a microphone. So from the left end we are taking signal and from the right end we are taking another signal. This is fed to the summer. So here we are having ML of T plus MR of T, that is addition signal. Here we are going to have the different signal ML of T minus MR of T. So this addition signal which is directly going via pre-emphasis network without doing any changes, which is directly going to this summer. In the different signal, we are taking this different signal, and after pre-emphasis, why we are in need of pre-emphasis network? Because our signal is going to have amplitude of either it may having low frequency component as well as high frequency component. But the signal, both the signals with respect to frequency or with respect to time, our signal M of T, which is having either a weaker signal or it may have a strong variations, but in order to reach the receiving section, we need to emphasize, that is boost up the high frequency component so that it can effectively reach the receiver. this after this pre-emphasis network, we are using a DSP-SC modulator. The purpose of DSP-SC modulator is to achieve the here this by using this carrier signal, 19 kilohertz is fed to the frequency doubler. So here we are having in 38 kilohertz. Here this whole purpose is for modulation. So addition signal is directly going here. 19 kilohertz signal is, we are using this as an pilot tone. That is, we are using this signal as an reference for receiving section. If this is my transmitter section, my receiving section is going to have this 19 kilohertz signal as a reference for my coherent detection, and this DSP-SC modulator is going to perform the frequency modulation. So here FM modulator and transmitter. So after so my signal part is going to have, if this is my 15 kilohertz signal and this is my 15 kilohertz signal, that is bandwidth of audio frequencies having 15 kilohertz, my initial addition signal ML of t plus MR of t will give 0 to 15 with respect to F, and this DSP-SC modulator will give from, it will start around at 38 because we are having a frequency doubler of 38 kilohertz. Therefore 23 plus 15 and minus 15 and plus 15, here we'll have 53 kilohertz. Everything is in terms of kilohertz. This pilot tone, this is occurring at 19 kilohertz. So this is going to act as an reference for the receiving section. So this is our ML of t plus MR of t, and this is our pilot tone, and this is our DSP-SC signal, that is XL minus XR or ML and MR, whatever the term which we are using for the reference. This carrier is obtained by doubling. This DSP signal so we are having three terms. One is due to the addition term, second is due to the pilot term, third one is due to the DSP-SC modulator. Therefore, in the receiving section, we are going to have taken this FM output. This is passed through three types of filters. One is the low pass filter. Second one is the band pass filter, which is having the frequency between 23 to 53 kilohertz, and the third one is the narrow band filter to filter out the 19 kilohertz signal. Therefore, this 19 kilohertz will pass through here. This is for the ML of t plus MR of t, some signal. That is, we have added our left and right part of signal, right? That will go for this low pass filter. This is our FM modulated signal. This is our FM modulated signal. So what will happen here? Similar to the pre-emphasis network, we will have de-emphasis to remove the distortions which we have introduced in the pre-emphasis part, and this is directly going to the summer. What this will do? This will try to extract the DSP-SC from the DSP-SC modulator. This is coherent detection. What coherent detector will do? It will try to take this frequency and do the frequency doubler, that is just double the frequency and then apply it to the coherent detector. So it will act as a carrier, and then the resultant signal will be here. It will having 19 kilohertz. Here it is, I will be having 18 kilohertz. The resultants will have the summation signal, which is again passed through the de-emphasis network. So this is XL minus XR, XL plus XR. This is XL minus XR. So this signal The resultant signal is separately applied to the loudspeaker, which is passed through two loudspeaker for stereo. If in case of monophonic, this particular path alone is useful for this monophonic. This particular path alone is sufficient for monophonic. That is only the summation signal. This particular path. If we are having an stereophonic type of transmitter and receiver, then we have to use this two loudspeaker, one separately for addition signal, one separately for different signal. So this is our, so here we have got this spectrum, and this narrowband filter is filtering out this pilot tone. This bandpass filter is filtering out this part of spectrum, 23 to 53 kHz. For effective recovery, we are using the pilot tone, and then after doubling we have 38 kHz. The effective recovery is done here. XL minus XOR of T. This is XL plus XOR of T, which both the signals are fed to the loudspeakers here. So this is referred as FM stereo multiplexing. This is FM stereo receiver. This is one of the application of FM. Now we are going to see FM transmitter as well as FM receiver. We already know two methods in FM transmission, that is in generation or modulation. In the generation, we have studied two methods. What are all the two methods? One is indirect method, or we can refer it as Armstrong method. Second is direct method. So we are going to see what are the blocks involved in this indirect method as well as in direct method. Indirect method is can also mentioned as named as Armstrong method. So what our indirect method will consist of? It is having an modulating message signal. Message signal, it cannot be directly applied to the narrowband phase modulator. Therefore, I will do pre-emphasis. After pre-emphasis, it is applied to the integrator. Therefore, 0 to T, M of T dt. So this the dt, the resultant signal will be applied to the audio amplifier. So what will happen here? I am having an M of T signal, which is the high frequency components are boosted up here in the pre-emphasis network, and the resultant of integrator is integrated over 0 to T M of T dt. So this part is allowed as for our message signal integration. This is a total incoming signal. Then what is carrier part? In indirect method, we will have a crystal oscillator, which is generally a low frequency carrier. And then we are feeding this carrier oscillator to the buffer amplifier, and then fed to the narrowband phase modulator. Narrowband NP, PM stands for narrowband phase modulator. Therefore, the two inputs for narrowband phase modulator is, one is my crystal oscillator, which is having the low carrier frequency. The another input is from the message signal. So this is my carrier part, this is my message signal, this is my carrier. So what is my resultant? My resultant is my narrowband frequency modulated signal. So how to obtain my wideband signal from this narrowband? We have to go for the help of frequency multipliers. So if I have a frequency f1 here, I have to multiply it with n. Therefore, my output signal will have a frequency of n into f1. We have to use series of frequency multipliers, that is chain of multipliers. This frequency multipliers, after this we have to this is applied to the mixture, and with the help of, in order to maintain the stability, because we have used a series of frequency multipliers in order to boost up the stability with the help of crystal oscillator. Here we are going for the help of crystal oscillator. The resultant signal is again amplified using the class C power amplifiers. So this is our transmitter section. After this, it is fed to the antenna. So this is our total FM transmitter section using the indirect method. Then what is the difference in for direct method? Instead of using the crystal oscillator, we are going for the help of reactance modulator. That is, we are using either varactor diode or reactance modulator. So the block diagram will slightly change. Here we are using a reactance modulator. It will act as an oscillator depending upon the control voltage. So this reactance modulator, directly we are feeding the message signal after pre-emphasis. After this set of pre-processing, so this is our message signal path directly feeding to the reactance modulator. So according to our amplitude variation, here frequency is going to vary. We are in this crystal oscillator part is missing. Therefore, what will happen? This reactance modulator is having the modulated signal which is fed to the buffer and passed to the driver to propagate the signal, and with the help of class C amplifiers, again it is fed to the antenna for transmission. But in order to maintain the stability in the frequency reactance modulator, here we are employing an feedback path slightly after this buffer. What will do, this feedback path, it will go for the mixture with the help of crystal oscillator. And this is my crystal oscillator. It will try to maintain the change in frequency here. That is, it helps to maintain the frequency deviation. This mixture will detect the change in frequency and it will be applied to the FM detector. It will give again applied to the low pass filter. This is applied to the reactance modulator. So what will happen, if whenever I will detect any changes in the reactance modulator, that is either greater or lesser, it always have to maintain this center frequency as FC. My frequency deviation is from FC plus F or FC minus F. Whenever I will get drift or variation or distortion in it, I will try to detect from using with the help of mixer circuit and crystal oscillator. It will detect any changes. If I get any changes here, it will come as a DC voltage pass to the low pass filter. This DC signal will help to maintain this drift in stability in the reactance modulator. This feedback loop, this entire path is referred as the feedback loop. We will try to maintain the stability. So this is for direct method, this is for indirect method. Now we are going to see FM receivers. We have seen FM transmitter using direct method as well as indirect method. In FM receiver, we are going to see the super heterodyne receiver, the same which we have seen in the AM receiver part, super heterodyne receiver. So in super heterodyne receiver, what it will do? It will try to tune the receiver section to the intermediate frequency. IF stands for intermediate frequency. So whatever may be my modulated signal carrier frequency, I will try to maintain the circuit, or I will try to keep the resonant frequency in the receiver circuit using this IF. But intermediate frequency for FM signal is 107 MHz. What is the intermediate frequency for AM signal? 455 kHz. Just we'll have to keep a note of it, and we'll draw the block diagram for this. We'll try to receive the modulated signal via receiver. After that, this RF amplifier we will try to boost the weak signals. It will be applied to the mixture. So what the another input for mixture is the local oscillator. So local oscillator is having the frequency. So this and this are ganged together. Ganged means tuned together, are connected mechanically, so that if I change a frequency here, both in RF amplifier as well as local oscillator will get the same frequencies. I'll try to maintain the or else I'll try to tune this RF amplifier as well as local oscillator to a same frequency. This is my receiving antenna. So I am going to take the band pass signal. This only the sum signal I am going to take. I am going to remove the difference signal. This IF amplifier will just amplify the series of, with the help of series of IF amplifiers. We will try to limit the noise stage by using the noise limiter circuits, because here we will be having our circuit may be having 88 MHz to 108 MHz. This local oscillator is tuned from varying from 98.7 MHz to 118.7 MHz, so that any frequency which may be having lying in between 88 MHz to 108 MHz needs to be passed through, and here this IF amplifier is having a constant fixed frequency of 107 MHz. So after this path, it is applied to the frequency discriminator. Frequency discriminator, we can apply slope detector, single slope detector or dual slope detector, and this is our feedback path. This feedback path is applied to the local oscillator if at all we have detected any changes. Feedback path is using automatic frequency control. After this frequency discriminator part, we are employing de-emphasis network to eliminate whatever may be the amplitude variations which is introduced during the pre-emphasis. After an audio amplifier, which is fed to the class A power amplifiers. In the transmitter part, we have seen class C power amplifiers. In the receiver part, we are employing class C power amplifiers. So after this series of power amplifier chains, we are feeding it to the loudspeaker. So this is our super heterodyne receiver. So this part is this part alone is my frequency discriminator or FM demodulator. We can either employ an slope detector So this is our super heterodyne part. Here we can employ high gain IF amplifier in order to limit the noise. This particular purpose is to eliminate the noise. Okay, and if I have this RF amplifier will always try to eliminate the capture effect. If I have a frequency like 88 image frequency, either 109.4 megahertz or 108 minus of 2 into 10.7, therefore 86.6 megahertz, everything will be lying inside the range. Therefore image frequencies will be rejected and it will try to capture only the frequency having stronger signal. That is, if I am having two stations, both are having the same frequency, but one is having a stronger variations and one is having weaker variations, then the signal which is having strong signal, the signal which is having a strongest power is going to be applied to the that signal is going to be filtered in this RF amplifier, detected in this RF amplifier. Only the strong signal. Weak signal will eliminated here, but in AM receivers there may be a chance of receiving both strong signal as well as weaker signal, but here in FM receiver part only the strong signal will be detected. This frequency drift is of here AFCs tried to avoid the frequency drift. This automatic feedback loop is Automatic frequency control is used to avoid the frequency drift. In general, FM receiver will provide high signal to noise ratio, but offering the wide bandwidth. So always they will have a trade-off between bandwidth and signal to noise ratio in FM. So this concludes our second unit.